Hey everybody, and welcome to McArdle Math Academy. In this video we will be talking about the comparison test as it relates to improper integrals, and in particular an example involving this improper integral here from 1 to infinity of 2 plus cosine of x over the square root of x, all with respect to x. We want to figure out if this converges or diverges. The first step here is that we're going to identify what our function is, so this is what we'll call f of x in the preceding arguments. Alright, and from there what you want to do is figure out what f of x behaves like for big X. So, let x go to infinity and try to figure out what pieces of f of x actually control how this thing behaves for large X. Cosine of x is always between. Alright, so cosine of x, this little piece here, always just oscillates between -1 and 1. It's never smaller than -1, it's never bigger than 1. Alright, so the numerator, in general, is never bigger than 3, and it's never less than 1, because you have 2 plus 1 is 3, and 2 minus 1 is 1. So that numerator is pretty much constant. It oscillates a little bit, but it's pretty much constant. So the whole thing's going to behave just like 1 over the square root of x, which I'm going to write as 1 over x to the 1/2. Alright, and for our arguments we're going to say that this is actually a over x to the 1/2, where a is some constant. So that's the behavior function for large x. Now what we're going to do is we're going to use this function that we found, g of x, to guess how f of x behaves, or how this integral behaves, whether it converges or diverges. So here's our guess. And for the guess, essentially what you're going to do is you're going to look now at the integral from 1 to infinity of g of x and figure out if that converges or diverges. Alright, now this is a very simple integral that we learned in the previous section, and it involves the what we call the p-test. So let's review the p-test for a second. So what the p-test says is if you have an integral from 1 to infinity of a over x to the p, this will converge if p is bigger than 1. Alright, so if the denominator is, say, x squared or x to the third, then we're going to have a convergent integral here. However, it diverges if it's less than or equal to 1. So this is the situation that we're in right here because the limits are 1 to infinity. But there's also another version of the p-test, just to review it. It doesn't apply here. From 0 to 1. And the results are opposite, so this integral converges if p is less than 1 and diverges if p is bigger than or equal to 1. But for our sake here, what actually matters is that our p is 1/2, and I'll show you why in a second, and we're in this situation here. Alright, so we find that we're actually in a divergent case because p is less than or equal to 1. Okay, so now let's head back to our work over here. And the reason why I got 1/2 is you can see the 1/2 right here. So our conclusion is that this thing diverges so we guess that our actual integral is also going to diverge. Alright, so that's the setup for these problems. We first find what the function behaves like, and then we use that function that we found to make a good, educated guess on whether our improper integral converges or diverges. And then finally, all we have to do in order to apply the comparison test is show that f of x is related to g of x in a particular way. And because we're looking to show that f of x diverges, we already know g of x diverges. So essentially what we want to do is just show that f of x lives over g of x. And the argument there is as follows, because suppose g of x looks like this, and the integral from 1 to infinity is this red area, if we already know that that's infinity, that's divergent, then as long as we can show that f of x resides above g of x, it will have an infinite area under it, which would make the blue area here also infinite. Alright, so that's why we are looking for this inequality. So this is what we want to show. Alright, so in other words, we want to show that 2 plus cosine x over the square root of x is bigger than or equal to some constant a over the square root of x. And so then really all that this amounts to is figuring out what constant a to put there. So this is again what we want to show. And so we look at the numerator, just look at the numerator. 2 plus cosine of x is always bigger than or equal to 1. Alright, why? Well, cosine x runs between -1 and 1, so the smallest this will be is -1. So the smallest the smallest 2 plus cosine x will be is 2 plus -1, which is 1. So we maintain this inequality. And because that inequality holds, so we know that always holds, then I can divide by this positive quantity on both sides. And there I have my exactly what I want to show, because this will become my g of x by just setting a to be 1, and this is your f of x. Alright, so what's the conclusion? Here's the conclusion finally at the end here. So this is the conclusion here. We say that by comparing to the integral from 1 to infinity of 1 over x, there's your g of x. We use the comparison test, which is our famous result, to conclude that this integral, which is your f of x, that's the one we're actually trying to find, will diverge. Alright, hopefully this helps, guys, and I'll see you next time.